the Saffir-Simpson hurricane wind scale, or the Saffir-Simpson hurricane scale for short, classifies hurricanes are Western Hemisphere tropical cyclones that exceed the intensities of tropical depressions and tropical storms into 5 categories distinguished by the intensities of their sustained winds. To be classified as a hurricane, a tropical cyclone must have maximum sustained winds of at least 74 mph per hour. The highest classification in the scale, Category 5, is reserved for storms with winds exceeding 156 mph per hour. The classifications can provide some indication of the potential damage and flooding a hurricane will cause upon landfall. Officially, the Saffir-Simpson hurricane wind scale is used only to describe hurricanes forming in the Atlantic Ocean and Northern Pacific Ocean east of the international date line. Other areas use different scales to label these storms, which are called cyclones, or typhoons, depending on the area. There is some criticism of the SSHS for not taking rain, storm speed, and other important factors into consideration, but SSHS defenders say that part of the goal of SSHS is to be straightforward and simple to understand. History: the scale was developed in 1971 by civil engineer Herbert Saffir and meteorologist Bob Simpson, who at the time was director of the U.S. National Hurricane Center. The scale was introduced to the general public in 1973, and saw widespread use after Neil Frank replaced Simpson at the helm of the NHC in 1974. The initial scale was developed by Saffir, a structural engineer, who in 1969 went on commission for the United Nations to study low-cost housing in hurricane-prone areas. While performing the study, Saffir realized there was no simple scale for describing the likely effects of a hurricane. Mirroring the utility of the Richter magnitude scale in describing earthquakes, he devised a 1/5 scale based on wind speed that showed expected damage to structures. Saffir gave the scale to the NHC, and Simpson added the effects of storm surge and flooding. In 2009, the NHC made moves to eliminate pressure and storm surge ranges from the categories, transforming it into a pure wind scale, called the Saffir-Simpson Hurricane Wind Scale, SSHWS. The new scale became operational on May 15, 2010. The scale excludes flood ranges, storm surge estimations, rainfall, and location, which means a Category 2 hurricane which hits a major city will likely do far more cumulative damage than a Category 5 hurricane that hits a rural area. The agency cited various hurricanes as reasons for removing the scientifically inaccurate information, including Hurricane Katrina and Hurricane Ike, which both had stronger than estimated storm surges, and Hurricane Charlie, which had weaker than estimated storm surge. In 2012, the NHC expanded the wind speed range for Category 4 by 1 mph per hour in both directions, to 130–156 mph per hour. With corresponding changes in the other units, instead of 131–155 mph per hour. The NHC and the Central Pacific Hurricane Center assign tropical cyclone intensities in 5-knot increments, and then convert to mile per hour and kilometer per hour with a similar rounding for other reports. So an intensity of 115 knots is rated Category 4, but the conversion to miles per hour would round down to 130 mph per hour, making it appear to be a Category 3 storm. Likewise, an intensity of 135 knots is 250.02 km per hour, which according to the definition used before the change would be Category 5. To resolve these issues, the NHC had been obliged to incorrectly report storms with wind speeds of 115 kn as 135 mph per hour, and 135 kn as 245 km per hour. The change in definition allows storms of 115 kn to be correctly rounded down to 130 mph per hour, and storms of 135 kn to be correctly reported as 250 km per hour, and still qualify as Category 4. Since the NHC had previously rounded incorrectly to keep storms in Category 4 inches each unit of measure, the change does not affect the classification of storms from previous years. The new scale became operational on May 15, 2012. Categories: The scale separates hurricanes into 5 different categories based on wind. The U.S. National Hurricane Center classifies hurricanes of Category 3 and above as major hurricanes, and the Joint Typhoon Warning Center classifies typhoons of Category 4 and 5 as super typhoons. Most weather agencies use the definition for sustained winds recommended by the World Meteorological Organization, which specifies measuring winds at a height of 33 ft for 10 minutes, and then taking the average. By contrast, the U.S. National Weather Service, Central Pacific Hurricane Center and the Joint Typhoon Warning Center define sustained winds as average winds over a period of 1 minute, measured at the same 33 ft height. Central pressure and storm surge values are approximate and often dependent on other factors, such as the size of the storm and the location. Intensity of example hurricanes is from both the time of landfall and the maximum intensity. As a result, it is not uncommon for a pressure to be significantly higher or lower than expected for a specific category. Generally, large storms with very large radii of maximum winds have the lowest pressures relative to its intensity. The scale is roughly logarithmic in wind speed, and the top wind speed for Category C can be expressed as 83 x 10, c/15, miles per hour rounded to the nearest multiple of 5 euro, except that after the change mentioned above, Category 4 is now widened by 1 mile per hour in each direction. The 5 categories are, in order of increasing intensity: Category 1, very dangerous winds will produce some damage. Category 1 storms usually cause no significant structural damage to most well-constructed permanent structures. However, they can topple unanchored mobile homes, as well as uproot or snap numerous trees. Poorly attached roof shingles or tiles can blow off. Coastal flooding and pier damage are often associated with Category 1 storms. Power outages are typically widespread to extensive, sometimes lasting several days. Even though it is the least intense type of hurricane, the storm can still produce widespread damage and can be a life-threatening storm. Examples of storms which made landfall at this intensity include Danny, Jerry, Hernan, Claudette, Gaston, Humberto, Sherry, and Barbara. Category 2, extremely dangerous winds will cause extensive damage. Storms of Category 2 intensity often damage roofing material and inflict damage upon poorly constructed doors and windows. Poorly constructed signs and piers can receive considerable damage and many trees are uprooted or snapped. Mobile homes, whether anchored or not, are typically damaged and sometimes destroyed, and many manufactured homes also suffer structural damage. Small craft in unprotected anchorages may break their moorings. Extensive to near-total power outages and scattered loss of potable water are likely, possibly lasting many days. Hurricanes that peaked at Category 2 intensity, and made landfall at that intensity, include Diana, Erin, Alma, and Ernesto. Category 3, devastating damage will occur. Tropical cyclones of Category 3 and higher are described as major hurricanes in the Atlantic or Eastern Pacific basins. These storms can cause some structural damage to small residences and utility buildings, particularly those of wood frame or manufactured materials with minor curtain wall failures. Buildings that lack a solid foundation, such as mobile homes, are usually destroyed, and gable end roofs are peeled off. Manufactured homes usually sustain severe and irreparable damage. Flooding near the coast destroys smaller structures, while larger structures are struck by floating debris. A large number of trees are uprooted or snapped, isolating many areas. Additionally, terrain may be flooded well inland. Near total to total power loss is likely for up to several weeks and water will likely also be lost or contaminated. Examples of landfalling storms of this intensity include Carol, Alma, Celia, Alicia, Roxanne, Fran, Isidore, Lane, Carl, and Sandy. Category 4. Catastrophic damage will occur. Category 4 hurricanes tend to produce more extensive curtain wall failures, with some complete structural failure on small residences. Heavy, irreparable damage and near-complete destruction of gas station canopies and other wide-span overhang-type structures are common. Mobile and manufactured homes are often flattened. Most trees, except for the hardiest, are uprooted or snapped, isolating many areas. These storms cause extensive beach erosion, while terrain may be flooded far inland. Total and long-lived electrical and water losses are to be expected, possibly for many weeks. The Galveston hurricane of 1900, the deadliest natural disaster to hit the United States, peaked at an intensity that corresponds to a modern-day Category 4 storm. Other examples of storms making landfall at this intensity include Hazel, Audrey, Flora, Cleo, Frederick, Joan, Einke, Louis, Charlie, and Dennis. Category 5. Catastrophic damage will occur. Category 5 is the highest category a tropical cyclone can obtain in the Saffir-Simpson scale. These storms cause complete roof failure on many residences and industrial buildings, and some complete building failures with small utility buildings blown over or away. Collapse of many wide-span roofs and walls, especially those with no interior supports, is common. Very heavy and irreparable damage to many wood frame structures and total destruction to mobile manufactured homes is prevalent. Only a few types of structures are capable of surviving intact, and only if located at least 3 to 5 miles inland. They include office, condominium and apartment buildings and hotels that are of solid concrete or steel frame construction, public multi-story concrete parking garages, and residences that are made of either reinforced brick or concrete cement block and have hip roofs with slopes of no less than 35 degrees from horizontal and no overhangs of any kind, and if the windows are either made of hurricane-resistant safety glass or covered with shutters. Unless all of these requirements are met, the absolute destruction of a structure is certain. The storm's flooding causes major damage to the lower floors of all structures near the shoreline, and many coastal structures can be completely flattened or washed away by the storm surge. Virtually all trees are uprooted or snapped and some may be debarked, isolating most communities impacted. Massive evacuation of residential areas may be required if the hurricane threatens populated areas. Total and extremely long-lived extensive power outages and water losses are to be expected, possibly for up to several months. Historical examples of storms that made landfall at Category 5 status include the 1959 Mexico hurricane, Camille, Anita, David, Gilbert, Andrew, Dean and Felix. Criticism: some scientists, including Kerry Emanuel and Lakshmi Kantha, have criticized the scale as being simplistic, indicating that the scale does not take into account the physical size of a storm, nor the amount of precipitation it produces. Additionally, they and others point out that the Saffir-Simpson scale, unlike the Richter scale used to measure earthquakes, is not continuous, and is quantized into a small number of categories. Proposed replacement classifications include the Hurricane Intensity Index, which is based on the dynamic pressure caused by a storm's winds, and the Hurricane Hazard Index, which bases itself on surface wind speeds, the radius of maximum winds of the storm, and its translational velocity. Both of these scales are continuous, akin to the Richter scale. However, neither of these scales have been used by officials. Category 6, after the series of powerful storm systems of the 2005 Atlantic hurricane season, a few newspaper columnists and scientists brought up the suggestion of introducing Category 6, and they have suggested pegging Category 6 to storms with winds greater than 174 or 180 mph. Only a few storms of this category have been recorded. Of the 35 hurricanes currently considered to have attained Category 5 level in the Atlantic, only 17 had wind speeds greater than 175 mph and only 8 had wind speeds greater than 180 mph. Of the 14 hurricanes currently considered to have attained Category 5 level in the Eastern Pacific, only 4 had wind speeds greater than 175 mph, and only 1 had a wind speed at 180 mph. However, most storms which would be eligible for this category were from the Western Pacific and are referred to as super typhoons, most notably Typhoon Ida in 1958, Typhoon Nancy in 1961, both with sustained winds of 215 mph, Typhoon Tip in 1979 with sustained winds of 190 mph, and Typhoon Haiyan in 2013 with sustained winds of 195 mph. According to Robert Simpson, there are no reasons for a Category 6 on the Saffir-Simpson scale because it is designed to measure the potential damage of a hurricane to man-made structures. Stating that, when you get up into winds in excess of 155 mph you have enough damage. If that extreme wind sustains itself for as much as 6 seconds on a building, it's going to cause rupturing damages that are serious no matter how well it's engineered. See also Tropical Cyclone Scales, Beaufort Scale, Fujita Scale for tornado intensity with damage correlated to wind speeds. The system was also intended for applicability in hurricanes, and is utilized by engineers in hurricane damage assessment. Hurricane Engineering, RON Emergency Scale for measuring the magnitude of any emergency, List of tropical cyclones, List of Category 5 Atlantic hurricanes, List of Category 4 Atlantic hurricanes, List of Category 5 Pacific hurricanes, List of Category 4 Pacific hurricanes. References. External links: Saffir-Simpson Hurricane Wind Scale National Hurricane Center, an interview with Dr. Robert Simpson The Mariners Weather Log, April 1999, Q&A with Herbert Saffir The South Florida Sun Sentinel, June 2001.